Welcome back, my friends, to the show that never ends. In a prior video, I presumptuously titled How to Build Python Mostly Properly on NixOS. I described a way to build Python in an affordance called the nix-shell that is offered up by Nix, and using typical command line parameters in a way that mostly works. Despite the title of that video, it's still done mostly the wrong way for Nix. Now, this video, I'm not going to make any claims about how right it is, but it is more right than the last video. That's all I'll say about it. The right way, instead of using nix-shell, is to use the Nix language to describe the package, and that's the way you do that is the software you're trying to install. The way you do that is to create something called a derivation. Now, it's still worth watching the other video because it does describe how Nix is different and how it uses environment variables to specify configure flags, and it's basically the Python that comes up with is the same Python that we're going to come up with at the end of this video. It's just that Nix, the package manager, in the last video knew nothing about the fact that we had built Python. It sort of transitively knew that we had built Python by the fact that we had created this Nix shell, but it didn't really know that we were depending on it for Python. It knew that we were depending on them for the Nix shell. So here's what I'm going to do. I am going to I'm going to fail to compile Python in this way, with a something that is defines a derivation in a .nix file, and .nix files are just stuff written in the the Nix language, and they define something that's quite fundamental to Nix and how Nix works. Now, you can go read. I actually recommend people. Despite it being a PhD thesis, it is not nearly as dry as you might imagine. It describes pretty much this thing, which is that link there. It describes pretty much how the theory behind Nix and sort of how it's realized in the form of Nix package manager. And derivation is a strange word, sort of, because the reason it's called a derivation is because it's derived from a Nix expression. There are files in the nix-store, which I haven't actually talked about before. Well, maybe I did in that other Python video. But there are files in here that are derivation files, DRV files, and those are derived from Nix expressions that represent derivations that you write. Okay, but it is one of the least interesting things about them from the perspective of a consumer of Nix. It's very important to how Nix works, but the idea that these are derived from a Nix expression is immaterial to people walking up to the system. But it's got to have some name. That's the name that the PhD thesis author came up with. So be it. So these derivation files are static, and they are let's see. Let's just look at one of them. Copy. They are. I'm not exactly sure what this syntax is, but they are things like inside of here. We don't really specify, the paths of our build inputs, you know, that these things are other packages. We just rely on Nix to sort of figure that out for us. But inside of a derivation, it is reified inside of a derivation. It's made real inside of a derivation. And these DRV files represent these derivations. They point at concrete directories and files on the file system that represent both our derivation and the derivations of our inputs, and probably other derivations that I don't know about yet. So we can, for purposes of our video here, we can consider a derivation. You know, they are not the same thing at all, but you know, for sort of shorthand, we can consider a derivation a description of the way to build a package, more or less. And in our case, that's exactly what this is. So we have, oops, that's not right. I'm saving that for later. I haven't done this before. This is totally off the cuff. We have a, where did I put that? Where did I put it? Let's see. Pi derivation, we'll call this new Chris M pi 10 pi 10 next pi, no, so 310 pi dash 3 dot 10. And we're going to copy this stuff into it. Change this. Okay, so this is a Nix file. This is I suppose it's a single Nix expression. Is that true? I guess everything in functional programs is a single expression, but I don't know. Don't pay any attention to me. Again, like I gotta admit, I am not a language nerd. I am learning Nix along with you. I don't know. As a matter of fact, I don't know what this means. Like I don't really know, but I don't really have to, because, well, I mean, eventually I'll have to, but at this point, you know, you have to start somewhere, and you have to, you know, proceed with impartial knowledge, or sorry, imperfect knowledge, and you know, you kind of look a little dumb. I mean, I'm sure I look dumb to a lot of people that know Nix as this series goes on, but it really is the only way to learn things. There are people that I know many people who are developers and sort of tech people who really have a tough time learning new things, and usually at the root of it is a fear of looking stupid. I think that, well, sometimes, at least some of the people I know, and I think they think that a lot of these, you know, people who know a lot of things, you know, the knowledge just kind of washed over them, and they receive the wisdom of the ancients, and, you know, kind of know how things work just by osmosis or something. But that's not at all how this works. How this works is, in order to learn something, I think what those people do is they'll take a certain situation, and they'll say, I need to make a decision here. You know, for instance, let's just talk about this. I need to make a decision here. What does that mean? Can I decide not to understand that right now? And they'll often come up with an answer is no. I need to understand that right now. You know, but, you know, honestly, there are so many things about software and about tech stuff that is so detailed and so in the weeds, you know, that to have to know it right now is it's impossible to know it all right now. You have to proceed with imperfect knowledge. You have to just move forward. And what these people do is they'll take a look at that and they'll decide not to make a choice. They'll decide, you know, I can't proceed anymore because I don't know what that means. And not only that, but I'll never know what that means because I don't proceed. So it's a catch-22. They can't proceed because they don't know what it means. But the only way to figure it out is to proceed. So let's proceed. We proceed. That's what we do, right? So, let's just take a look at this function call here that we're making. Now, calling it a function call, again, I don't actually know. I think it's a function call. I mean, it's declarative, so maybe it's not executing a function. Yeah, I'm not sure. You know, I mean, I guess you could call it a function call. It's just a function. I don't know. I don't care. But what it does is it makes a derivation. Now, at this level of Nix, we are way up high. We're way up high inside of Nix. This make derivation thing, this package standard in make derivation thing, is, you know, this was not the first thing written in Nix. This is like the 20th or 30th or 50th thing written in Nix. You know, this is a function that uses a bunch of the framework that's below it. I think a lot of the Nix stuff confuses people because they don't know exactly which layer of Nix they're at. And the Nix docs, you know, they're pretty good. I mean, I hesitate to slam anybody for the docs, you know, because docs are hard. But they don't really give you a good sense of you know, where you're sliding in at, you know, and they don't really, you know, again, it is proceed with imperfect knowledge. I mean, the way the docs are, they assume that later you will understand the fundamentals of the system, but often it's hard to understand this top layer of the system without understanding some of the fundamentals of the system. But you just do the best you can. You do the best you can. So this set of docs here is really talking about a very high level of Nix, you know, and there's other things in the Nix docs themselves that describe how to create and debug packages, and you know, I mean, it is much more complicated and much simpler at the same time than this describes. So anyway, I'm rambling, but the thing that we have here is using this make derivation thing, which is way up high in the stack. It's way up high, and it builds on other stuff that's way down low in the stack. As a matter of fact, in NixOS or Nix docs that refer to derivations, you'll often hear lots of talk about a builder. Okay, now there's no builder mentioned here at all. There's name, source, and build inputs. That's it. No evidence of a builder. That's because it's using a generic builder. It's using like the default builder for this derivation maker, and that default builder is actually itself a derivation inside of the nix-store. So let's see here. I happen to know where it is. Well, this is a part of it anyway. So we can see that this builder is what's used by our make derivation thing. So it is all bash. It's bash. Well, it's shell anyway. It's bash. That's just shell. I'm not even sure they can assume it's bash. It's just shell, you know. And well, this is one part of it anyway. The standard end thing is part of setup. We can see that setup is dependent on here. Oh boy. Standard end Linux, derv. We can see that even the standard end is a derivation, and that actually defines a bunch of the stuff that defines the very bottom layer of Nix. Now, a lot of Nix, people geek out over the purely functional stuff and the language and stuff, but most of it, I mean, I imagine the secret, the well-kept secret of this stuff is, I suspect that if you were to go to see what does most of the heavy lifting, what actually gets executed most of the time in a NixOS installation, it's going to be bash. I mean, it's going to be shell. All this stuff. Now, I am terrible at shell, and so I tend to try to stay away from it. But there is a heck of a lot of shell in Nix. So anyway, I know I'm going off into many territories here, but just stick with me. Okay, so this. Oh man, how do I describe this? So I'm gonna move this down some. Let's see. Okay, so what I wanted to say about that is that this builder, this generic builder that make derivation uses, assumes an autoconf style input, which means that it has a configure script. That generates a make file. The make file, when you run make, it builds the software, and when you run install, it installs the software. So it's CMMI in other worlds, as the assumption of the builder of this thing, which is true for Python, and we're trying to build Python. So why did I say that? Where am I? Ah, okay. I think I actually said that before. So sorry, I'm editing my video as I'm making it. Come on, man. What do you want? What do you want? Well, if we looked at this builder, this generic builder, we'd see that, when I say that Nix is in these layers, the builder itself is, I could be wrong about this. Please don't take this as gospel, but I think at the layer of the builder itself is kind of its own little framework, and it defines phases, and it's written in bash, and these phases can be overridden by creating functions or overriding it in the derivation call. But basically there's like there's a download phase, an unpack phase, configure phase, install phase, check phase, and these things are this framework is kind of distinct from the actual Nix language and the nix-store and stuff like that. It's a way to build software on Unix, which is important here because Nix actually, the concept is not particular to Unix. Now all the effort and all the actual work has been put into building software for Unix like systems, like Unix and Darwin and whatever. But in reality, I don't think there's much to Nix that is specific to Unix. You could build a Nix-like system, or you could use the concepts that Nix pioneers building Windows software. It'd be fine. But all that shell stuff, all this upper level framework stuff would not work. So you'd have to re-implement it again, and it might be implemented slightly differently for those platforms because they have different ideas about how you build software. So this is both a weakness and a strength of Nix, that it is a collection of frameworks that build on top of each other, and so we're talking about the Unix flavor of Nix, which is the only one right now. But you can see how this might get complicated. It's all convention, all this stuff, inventing frameworks on top of frameworks it's all convention. So let's try to run our Nix Nix Pi derivation. Okay, Let's try to run our new nix-m py310.nix. The way we do that is by using nix-build, and then we just pass it the name of the nix file. And nix-build, let's see what nix-build says about itself. No idea. Build a nix expression. Haha. One expression. Yes. Build a nix expression. So the file describes a single expression. Okay. I don't care about all the stuff in here now. All we have to know is that we are building an expression, and the expression lives in this new nix-m py310.nix file. All right, let's run it. All right, so we have a syntax error. Blah, 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 build inputs. Why do we have a syntax error? I copied this from something that worked. Oh. Sort of, I guess. Why is that there? Do we need that? That is not required. Okay, so the next thing we need is a. Okay, so is that. Does that have an ending thing? No. Again, I don't know much about this language. I am just hacking my way through it. So we can see that what it did was it tried to download a version of Python from GitHub. And it downloaded it fine, but then it said there's a hash mismatch in fixed output derivation, blah, 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 blah. So the reason for that is because I am faking out this SHA-256. I don't know what it is yet. And now I can, how did I find this fake thing to put in there? Just looking around, man. You know, there's no single head of Zeus in charge of this operation here. So, you know, I just looked at other things and how they did it. So now I can put the actual SHA-256 in there. So now that I did that, I should build, or at least pretend to build. And this will take a while. You know, hopefully it won't fail, but I'm going to pause this video and I'll be back when it is all configured and made. Okay, well, it finished with an error. And, the reason it finished with an error is because by default, Python tries to, when make install is called. So remember that this thing went ahead and it called configure with a bunch of the flags that it took from the environment, make with a bunch of flags it took from the environment, then make install. And when make install is called, by default, it wants to set up pip. And the Python maintainers are very iffy about packaging. And for this reason, although in practice, almost everyone who uses Python will use pip or some, you know, particularly software developers will use pip to install Python packages. The core developers are not sold on the idea of I guess the fun, maybe not pip, but the fundamentals underlying pip. So it's this separate phase where we're ensuring that pip exists as if it matters. So, but it only happens during make install phase. And the reason it's doing this is because pip, and this is one of the reasons in my prior video where I talked about some of these quote unquote optional dependencies are optional to the Python core developers. They're really not optional to anybody but the Python core developers. They're used by almost everybody. And in this case, it can't run this ensure pip thing because the underlying reason for this is because the way ensure pip works, it relies on having a zlib module, which by default we don't have. So This is expected. I expected this to happen. So in my prior video, what I did in order to get around this was I put a file into the modules slash setup. I put some contents into the file named modules slash setup.local, and that had information in it that Python used to sort of get around the fact that the libraries that Python's compilation step depends on are not in the same places on Nix as they would be on virtually any other Linux distribution or any other Unix distribution for that matter. They're instead inside the nix-store, and because Python doesn't know about Nix, it can't bridge the gap. So we have to feed it a little bit of information for it to do that. I have no idea whether there's a right way to do it. I suspect not, but it is a way to do it. And the way we do that is we put another. All right. We add an argument to our call to make derivation, and let's put it here just for fun. 2 1 2 1 2. Right. Is that no. Yeah. Okay. So basically, we're doing the same thing as I did by hand in the last video, where I created this setup.local file. We're just using a shell script to create the file rather than copying it in place or editing it in place. So the root of the current working directory as this thing runs is the build root of the software. So is that right? The source root of the software, I guess. Yeah, source root of software, which is in our case something like downloads, something like this. We're in here, and so what this command does is it says create a file named modules relative to where we are, which is inside of this Python 3.10.5. An untarred version of this that Nix does as a result of running this make derivation thing. Put a file with these contents in it, and these contents are, it is a way to get around the fact that Python uses sort of this really sketchy way to go find the library dependencies it needs to build these optional modules. We just tell it, hey, forget all that. We know where all these things are. So this is correct for some definition of correct, in the same way that my last video defined it as correct for some definition of correct. So now that we do that, well, let's take a look at what happened here. So we got an error, and under normal circumstances, let's take a look. Let's just do this. I've never done this before, but let's take a look at what it says about our build here. So note that this bit of cruft here is the hash of the derivation. Is that true? Hash of derivation? Sure, why not? Hash of derivation that we just built. And that is just a, some, I don't know, is it 128-bit, 64-bit? I don't know. Representation of the specified inputs of the derivation plus anything in this that we use to make the derivation. Like I think it's some variation of all the inputs here. Python, CPython, the post patch stuff, all that stuff, plus all the hashes of these things, these build inputs here, which are themselves derivations. So anyway, so if we do this, okay, cool. That's really cool. Okay, we can see pretty succinctly what it's doing here. We can see that it does an unpack phase first, then it does a patch phase. Patching sources. I wonder if it actually ran this. I don't know whether my post. Oh, we haven't done that yet. Okay, yeah. So there's nothing. And okay, so we see all the output of Python as it tried to compile itself. Now it's installing. Okay, so we can see the actual error here. Yeah, so that's how I know that this thing wanted zlib. This would happen if I had done what Nix does under the hood. So that's useful. And now that I've done this, now I've added an argument to this function call, and I want it to, this packages libs.concat string sep, again, this is all unpack here, man. Like, I don't know. I just found this somewhere and decided that this was an okay way to do this. There's probably some higher level thing that I could have used called, put file in source directory or something instead of using bash to do this, but I couldn't find it. So I did this. And this, concatenates these things with a control N. I'm not even sure. I'm sure this is just too much tool for this job, this concat string set, because I only have one string. But anyway, it works, and it makes the side effect of running it makes a module setup.local. So now that we've done that, we can now go back to where we were, and let's make our nix-build again. All right, now I think as a result of putting that stuff in there, I'm not entirely sure. I guess it'll be interesting to find out. I think that this hash is going to change because it's just new inputs to the thing, but not totally sure. Let's copy that. Let's find out. Okay. Really? How do I unbuild it? Why didn't it do the stuff it did? It needed to do over again. Oh man, my world is crumbled. I thought it would just kind of like a makefile, like understand that the inputs have changed and do the needful again. I honestly don't know how to fix this. I don't know how to fix this. Well, one way to fix it. This is the wrong way to fix it. Well, yeah, what I'd like it to do is I'd like it to just do that again. Now, what did it put in there? What did it put in this new derivation? Oh, by the way, this is the output of nix-build is a single line, which is the path in the store that our derivation is at. Maybe this is a Python thing. Is this a Python thing that it didn't need to do anything? It thinks it didn't need to do anything? Oof. Ooh. But did not obviously it didn't re-download the thing. It would have taken a while. It didn't even run configure it, did it? What if I run this against the new? There's not even a new derivation. My mental model of how this works is is clearly broken. So here's what I'm going to do. Just for the meantime, I'm sorry, folks. I did not expect this outcome. This is part of the head of Zeus thing. I don't know how this stuff works in reality. I am learning along with you guys. So I'm going to remove this derivation, and the way I'm going to do it is going to horrify, I'm sure, most experienced Nix users. But we're just gonna remove it from the store. So remove that. They're way smarter than I am. Oh, it's so funny. Oh, that's so funny. They're like, nope, dude, go learn. dude, don't. Come on, dude. Really? All right, well, I'm going to have to figure out how to remove some from the store the right way. Before I can continue, I'm sorry, I'll press pause. I'll figure it out. I'll be back. Well, that was fun. I had noted later on in my script here that I did not know how Nix knew to keep, you know, your derivation alive. Well, now I know. I had to know. My learn as you go was necessarily preempted, a step ahead of where I wanted to be. But so in my mucking about here, where we were before was I had run nix-build against my derivation, and it didn't actually do anything. So I'm still a little unsure as to why that is. Although I think I might have made a mistake. I'll have to review the footage, but I think what I did was I ran like nix-build chrism this instead of new chrism, and I'm not entirely sure. I think if I had run it against new chrism, it would have done that. I probably should stop and find that out at this point, but I'm not going to because I have to finish this video. But here's what I learned. The way that the nix-store works, well, the way that at least the way that the nix-store knows to keep around derivations. Now, like you can actually run nix collect garbage at any time, and it will delete what it thinks are unused derivations. I really didn't understand how that worked before, but I understand a little bit better now. So the derivation that we built is inside of there are a number of variations. Now I've run this some number of times already, and this this derivation I've run a number of times, and I believe that it's created a number of actual derivations plus the source plus their builders, and the way that now when we run NixOS build nix-build, and remember that the thing that it spits out at us is the directory of the derivation that it built, not the derivation file, but the directory. It actually, now I've built this a number of times, so you'll probably find that this isn't the same hash as the one that I had been copying and pasting before. This is different. But at this point, what I want to do is I want to just get rid of anything that mentions chrism pi 310 in the nix-store, and that will allow us to sort of build from scratch. the reason now, if I run NixOS collect garbage, I don't think that it's going to do that for a number of these in here. All of these things are various versions of the derivation that I built. I think what I have to do is delete these things, or at least make them deletable. Well, delete these things individually. So the first thing I'm going to do is delete the derivation that I built. So we can see the ones that I care about here because they're all named Chris M Pi 310. The way that we take a look at how our derivation is actually used or is referenced by the nix-store is we use a nix-store -q -roots command, and this will give us the garbage collector roots of the derivation. So if we do that, I have to run sudo because I can't read it otherwise. We see that inside of when we run that, we get 3 outputs. We see that it's used in the environment of a couple processes, and that we also see that it's used in the result file, well, result symlink anyway, of our build here. Now, honestly, I'm not sure if we just delete this symlink whether it would go away. I don't think it will. We could try it. I happen to know that these, so if I run nix-store roots again, you can tell that these are ephemeral processes. This is coming back as a result of somehow the nix-store command running. So I don't think those are permanent. But I don't think that if I delete this result directory here, that will actually give me the desired result. We can try it. And so now that we've deleted result directory, we can try to delete, oops, this is wrong. Delete. We try to delete, yeah, try to delete our derivation. I don't know if I do it again if it works. No? Okay. So we take a look at the roots that it thinks it has. Okay, so it's kept alive by something in the environment. So I imagine if I rebooted and then ran nix collect garbage, that my derivation would probably disappear. Which is that's actually the reason the last video was not where I compiled things using nix-shell. I wasn't certain how long it would keep around the stuff in the store. I'm still not all that certain, but I'm learning here. So in any case, for now, although I don't know exactly what I'm doing here, but I don't care. If we pass this flag, I can delete this derivation. So now, if I do ls of that, we can tell that derivation's gone. I sort of just want to rinse and repeat for all these derivations in here because I've done this a number of times. I don't exactly know what those represent. Don't really care. WCZ copy. All right. Okay, so again, I'm operating under partial understanding of how this whole thing works. I don't know why it doesn't delete the DRV files. Earlier. But yo, man, we're getting there. We're getting there. So now that we've taken that side tour into how the nix-store works, we can rebuild our Python here with, and again, partial knowledge. I do not understand. I don't quite understand why. Maybe it'll become obvious when I review the footage of this. Why adding this post patch thing to our make derivation call didn't cause it to be rebuilt. But let's just go with it. So now if I run nix-build new crismpy, it should rebuild the derivation, and it does. So I will pause this. I'll be back once this finishes. While this thing is still going, I wanted to mention one thing that I sort of glossed over when I was talking about deleting stuff from the nix-store. You can't just delete things from the nix-store. They have to be unreachable from a garbage collector root in order to delete them. So when I ran nix-store -- delete, it's just a much more specialized case of wanting to delete a specific derivation than running a nix collect garbage or any garbage collector call. You just can't delete something from the nix-store if it is reachable from a garbage collector root. So you have to do that whole shenanigan thing I talked about there, where you find the root and then delete it. Although I'm not entirely sure why I had to ignore liveness. But we're getting there, man. I don't know. Anyway, what I wanted to say was nix-store -- delete is just a specialized version of nix collect garbage. That's all. Okay, well, it finished, and it did take account of my post patch thing, which put that module setup local in there. That's the reason why it finished properly. That's the reason why it finished without an error. And it spit out our derivation path. So let's take a look at the log that it how do we take a look at the log now that it's built? Okay. So I still don't quite understand when our post patches actually run. It doesn't output anything, so it's not all that surprising. There's no standard error standing out to that. So maybe it happened as a result of patching sources here. That's possible. Likely. So, but we can actually take a look at. Did I run that through less? Okay, so we can see that it did a bunch of stuff, compiled our stuff. I think this is just the output of. No, it's not just the output of that, but some of this output here is incorrect. It did find a lot of this stuff. This is just the way Python works. It didn't know it found the stuff at this point in the process because it was trying to use the setup.py file to find the libraries. It didn't find them. However, okay, so this is the next step, which is to how do we know it actually worked? How do we know our Python is running or is runnable? So I actually came up with a little script here. This should be a shell script, but it's not. It's a Python script. Excuse me, I'm sorry. It's a Python script. This should be a shell script. So let's see, run build py. So what this script does is it runs nix-build crismpy. Well, I should tell it to run this new crismpy. You can't fool me, old me. It's going to print the store path, and then it's going to run run these commands. We're going to just import these modules that it wouldn't have built before had I not put that setup local in there. And for the reason why, you can look at the last video that I wrote, mostly correctly compiling Python, although that's incorrect. But okay, so now that we can run this with our existing Python, and this is called run build py. We're not going to see any output of this thing from this thing, even if it did go ahead and redo all the stuff that it just did, which I don't think it will. We wouldn't see any output from this thing other than what it prints on the screen here, so it's not all that unexpected. But it is running nix-build, and it will hopefully execute our created Python via store path here, bin Python 3, and then we'll run those commands against that Python. Did I get it right this time? Okay, there must have been something. Something must have happened where I had that typed incorrectly. But now it found the right file, and it ran nix-build. It printed our store path here, and then it ran Python, our built Python, and it executed these commands, imports ulib. So if there was a problem, it would have spat something as standard error. There isn't. It didn't. This is mostly success. This isn't the last word in how to compile Python or how to compile anything on Nix. There's much I have to learn. But this is an improvement over our nix-shell video where we compile Python, and hopefully will serve as a somewhat bumpy introduction to compiling anything on Nix for folks happen across it. So there's a few things that I know are wrong with this derivation. I'm not sure it's repeatable. There are inputs to it that I don't quite know about, probably, that I would have to ensure that it's, I'd have to run it some number of times and check the output against each of the runs to ensure that's repeatable. I'm not going to do that here, but it's not particularly easy to remember the path of our Python. It's in here. And that's not great, but there's a whole other side of Nix that I don't, or at least NixOS, that I don't quite understand, where it keeps sort of current set of software around. But that being said, you could build software like this and then just this would be knowledge that you had about where these Python versions are. Now, if I wanted to build a bunch of Python versions, I would just do this over and over again for every various downloaded for every version of Python that I wanted, and I would then probably create a directory that symlinked to each one of those things that were named py3 10.5, py3 10.6, whatever. We didn't run our command as the root user, so that means that it is local to this user, this Chris M user. That's not really a problem so much, but this is more of a video about Nix than it is about NixOS, because NixOS it lives and dies by what's inside of etsy NixOS configuration.nix. Our thing is not controlled with that. I'm sure there's a way to, if we wanted to. It's probably not all that desirable, actually, for this case. But if we wanted to, I'm sure there's a way to include our derivations into that tree of stuff that would happen as a result of running NixOS rebuild. Another question I put in here: how do we signify that our configuration requires this derivative? I guess I meant NixOS. Okay. So the actual NixOS derivative for compiling Python, although it's much more general than this is also much more complicated, because it has to take into account, optional flags, got to know what platform it's on, all kinds of stuff in here. And I'm not even sure that it names its build inputs. Okay, so it does name its build inputs. Okay, so chances are that if I in here I have all this nonsense about I didn't know whether you needed to specify the outputs, the dev outputs of these things separately. So probably if I replaced this stuff with if I replace this stuff with this list of build inputs, it might compile. It might compile. That's something for a future video. I got to call it a day here, man. So anyway, you could tell that this can get arbitrarily complicated here, as NixOS is. Generalize it so you can build multiple versions of Python on multiple platforms, et cetera, et cetera. But and it probably does it use make derivation? It does. It does. It's cool. Yeah, and it doesn't use fetch from GitHub. It uses fetch URL instead from python.org. I mean, it's just interesting to see the differences in here. Is Darwin. Okay, so they actually patch setup.py for macOS here. Interesting. Patches. Okay, so they have a bunch of patches in here. Yeah, so you could tell that it gets complicated when, as time goes on, you have to support multiple versions and multiple platforms. Anyway, so anyway, that is the video here. I am rather excited about Nix as a result of having success after success, even though the success is rather bumpy here, in understanding how it works. I started this out. The reason I started any of this trying to compile Python stuff out was I was coming from a world where I used a package called pipenv to install various micro versions of Python on a given system. And pipenv, all it does is it downloads the tarball of a particular version of Python. It builds it in a place that's on the file system, and then you put a symlink to it somewhere in there, and then you can run various micro versions of Python. For what I hope, given the topics we covered in this video, are obvious reasons, that doesn't work on Nix. And so I was in a place where I'm like, well, I need to do that sort of. I didn't really need to do it, but it seemed like a reasonable place to start to try to compile software on here. And I asked one of my NixOS maintainer friends. I said, "How would you do such a thing?" I think he misunderstood the question because I think he thought I was talking about virtualenv, not pipenv, or not pyenv. Did I say pipenv before? I meant pyenv. Pyenv is over here. This is pyenv. And on Manjaro and stuff, and on Ubuntu and on Mac OS, just works fine. You download every version of Python you want, including really strange ones like Stackless, whatever, PyPy, et cetera, pretty great project. It just makes life easy for maintainers that want to run tests for their software on multiple Python versions on multiple platforms. So. But I couldn't do that with Nix, and it was the one thing where I was like, oh, I don't know about all this, whatever. But it's just not applicable. It's just pyenv is not something you would use on NixOS. You're going to have to reinvent it, and that is the well, you might not have to reinvent it, but at least you'll have to figure out how to come up with an environment that has all that stuff in it, that has micro versions of Python available to you, and not just major versions of Python or minor versions of Python available to you with like NixOS does. The answer is moo. The answer is you asked the wrong question. And that's probably what my Doman, my friend, would have told me if I had asked the question in the right way. You just don't do that. So now I know that, and I'm okay with that answer. I'm perfectly happy with that answer. All right. Well, thanks for watching, folks. I hope this has been at least not boring.